Alright, so you'll go ahead and do the factoring and the math knowledge question, pause the video, and then when everyone finishes, go ahead and unpause it, and I'll show you the correct answers. So, this factoring is completely new from what you've done before. It has 4 terms, and so we're going to use something called factoring by grouping. And so what we're going to do is look at how these two can be factored. What do they have in common? Yes, they have an x squared in common. And so if you factor out an x squared, you're left with x minus 5. And then we're going to look at how these two will factor. So if you look here, those don't really have anything in common except for a -1. If we factor out a -1, we end up with x minus 5. Now the reason I wanted to factor out a -1, if you look, everything that's in the parentheses for these two is the exact same. They both have an x minus 5. This right here is the same as that. And so now what we can actually do is write it as x squared minus 1. So that x squared and that minus 1. And then they both get multiplied by x minus 5. But that's not all we can do. This x squared minus 1 will actually factor as x plus 1 times x minus 1. And then we have our x minus 5. And so this would be the answer to your factoring problem. We'll practice that some more over the coming days. But that's called factoring by grouping. And it's very useful. Sometimes you may have to rearrange the 4 terms depending on how they're given to you in the problem. So hopefully that makes a little bit of sense. Now on this math knowledge question, what you're going to want to do is make a Venn diagram. And we're going to have 3 circles for our Venn diagram because we have math, science, and we also have gym. So this is the math circle, this is the science circle, and then this is the gym circle. And so we're going to start at the bottom. It says 1 teacher teaches math, gym, and science. So that means that in this little box here, for part of the Venn diagram, we have 1. Now it says 2 teach gym only. So the gym only is going to go down here. Moving up, we have 5 teach math and science only, but they don't teach gym. So this part here is going to be a 5. Because those are the ones that teach only math and science, but not gym. And then both gym and science is 6, so that goes in that little slot there. And then it says 20 teach at least 1 class of science. Well, that means that everything in this circle here has to add up to 20. We have a 5, a 1, and a 6 already, so another 8 will make that total be 20. Because we have 20 people, 20 different teachers that teach at least 1 class of science. So now we're going to look at this next one. 10 teach 1 class of gym. So that means that everything in the gym circle should add up to 10. Well, we've got 6, 1, and 2. So that leaves us with another 1 that teaches, they teach gym and math, but they don't teach science. That's what that tells us. And then the last thing, we have 12 that teach at least 1 class of math. So all of these have to add up to 12. So we have 5 and 1 and 1. So that means 5 teach only math. So how many teachers teach math only? The correct answer would be C. So those were the answers for your factoring and your math knowledge question for today. All right, so we are looking at use substitution and change a variable, lesson 66. So hopefully after this lesson you'll understand use substitution and you'll also understand change a variable. So we want to integrate this. So we are going to try and figure out where we want to put our u. Well, we want to put a u somewhere that'll make it a little bit easier to integrate this. Some of you may already have this integrated without using use substitution, and that's completely fine. However, I want you to practice using the use substitution just in case you're having any issues, because sometimes it does help you on problems in the future. The easiest thing that you're going to want to use your u for is the thing that is raised to a power, which is our x squared minus 4. And so if we plug in a u, we would make it u to the 5th. And so now we've got a u to the 5th instead of an x squared minus 4 to the 5th. So we take our du, and that gives us 2x dx, because the differential of 2x minus 4 is just 2x dx. Now, what we need to do, somehow we need to get 40x dx in terms of u. So if you look over here, I can divide this by 2, and x dx here and here is going to become du over 2. So I'm going to write it like this for you. The integration of 40 u to the 5th, and then x dx, I just put them together. So you have 40 u to the 5th, and then instead of x dx, that's 1/2 du, or du divided by 2. And so 40 times a half is actually just 20 u to the 5th du. And so now we're going to integrate that. So you integrate by adding 1 to the exponent. And then we're going to do 20, and we divide by 6. I'm going to go ahead and put my plus c so that I don't forget it. Now 20 over 6 will reduce to 10 over 3. And we can't leave a u in our answer. So our u, if you look back over here, we said was x squared minus 4. And so once we replace it, it's back into x, and this would be our answer here. So you use the u substitution, and then you're also going to have to figure out some way over here to get our x dx into a u. And so that's where you're going to use your du equation, and you're going to have to be, sometimes you have to be a little bit more creative than others. On this one, we just divide it by 2 to solve for it. But that's how those work. So let's look at this one. We're going to want our u to be what's in our radical. So we're going to say u equals b plus sine of ax. And so that means that the du, a and b are constant. So the derivative of b, derivative of a constant, is just going away. Now derivative of sine goes to cosine. But we have to remember to take the derivative of ax. Well, the derivative of ax, a is some number. And so that is just going to be a, and then we have dx because we took the derivative with respect to x. So let's come over here, and we can go ahead and say the integration. We have 20 cosine of ax dx, and then instead of the square root of b plus sine of ax, we can say the square root of u, because that's what we replaced. So now somehow we want to get rid of this cosine ax dx. Well, if you look over here, we've got cosine ax and we've got a dx. The only thing that we need to get rid of is that a. That's an a. So we can say 20, and then instead of the cosine ax dx, it is du over a. And then we have the square root of u. So now that we've made that substitution, everything is in terms of u. It also does have an a, but a is just some number here. So I'm going to go ahead and rewrite this. I'm going to have 20 over a, and then I'm going to have u to the negative 1/2, because I'm going to move it up to the numerator, and then du. So at this point, we can integrate it, because it's all in one variable. So we have 20 over a, and then u, negative 1/2, we add 1 to it. It's going to become a positive 1/2. So we're going to divide by 1/2, which is the same thing as multiplying by 2. And again, I'm going to go ahead and put a plus c so I don't forget it. So now we just need to simplify and replace. And our u is b, look back up here, plus sine of ax, and it's all to the 1/2. Now, if you'd rather write that with a radical, you can. That's fine with me. Doesn't really matter. But this is going to be your answer here. Okay, so let's look at this one. Again, we're going to use u substitution. Any ideas what we want our u to be? We want it to be x minus 1 because that's what's in our radical. And I can go ahead and take the differential, and I'll get du equals dx. So this one's a little bit different. If I replace my dx with du, I've got a little bit of an issue. I can replace those, but I still have an x right here. However, if you look right here, x equals u plus 1. If you just solve that for x. And so over here in our equation, we can actually say 7 and then u plus 1 times the square root of u du. So that one's a little bit different. You have to go back to that u equation and solve it for x. So now we're going to distribute, but before we distribute, well, we can go ahead and distribute the 7. And then I'm going to make u to the 1/2 instead of the square root of u. And so now we distribute. 7u times u to the 1/2 is going to be 7 to u to the 3/2, because 1 plus 1/2 is 3/2. And then plus 7u to the 1/2. And so that is it if you distribute it. And so now we integrate. So we add 1 to the exponent to get 5/2. And then we do 7. Instead of dividing by 5/2, I'm going to multiply by the reciprocal. And then we have u to the 3/2, because you add 1 to 1/2. And then 7 times the reciprocal, so 2 over 3. And I'm going to go ahead and put plus c so I don't forget that. So now you can go ahead and multiply, and you get 14 over 5. U to the 5 over 2, and then you get 14 over 3. U to the 3 over 2. And now we just need to plug in what our u was. If you look back up here, u equaled x minus 1. So we have 14 over 5, u minus 1 to the 5 over 2, plus 14 over 3, not u, this should be an x, I'm sorry. And then we would have x minus 1 to the 3 over 2, and then plus c. And this is how I would prefer you leave your answer, just like this. I'm going to show you. The book actually writes it like this. But I would rather you not do that. I feel like that's just more work for not much help there. So that's dealing with u substitution for integrations. Now we're going to look at an alternative procedure for evaluating definite integrals. It's not necessarily easier or simpler, but sometimes it's a procedure that's going to be more helpful. So sometimes this will be helpful to use a change of variable. It may not be easier or simpler for you, but it's going to be helpful. So it's called change in the variable of integration. So when we change the variable of integration, it's usually necessary to change the limits of integration as well. So let's look here. We're going to change the variable to evaluate this. So we're going to use a u substitution, just like we did on the previous problem. But on this one, we actually have limits here of 0 and 1 for our integration, and we're going to end up having to change those. So we're going to have u equals, we want to use pi x squared. And so du is going to be b 2 pi x dx. So we're going to come over here. We're integrating from 0 to 1. X sine of pi x squared dx. And so instead of pi x squared, we can make it a u. And now if you look here, we still have an x and a dx. Well, we've got an x and a dx here, so we just need to divide by 2 pi to get it to where we can substitute it in. So now we're going to have 0 to 1, the sine of u, and then our x dx is going to become du over 2 pi. So the problem, we can't integrate this and then plug in 0 and 1 because these were x equal values because it was originally in terms of x here. All of these were x equal 0, x equal 1, x equals 0, x equal 1. So what we have to do is actually figure out what our u limit values would be there. So if x equals 0, u would equal pi and then 0 squared. So our u is actually 0 as well. So our limit for u of our integration would be 0. But when our x is 1, when we go to plug that in, pi and then 1 squared, our u actually is going to be a pi. So our value up here for our upper limit is a pi instead of a 1. And so now we have 1 over 2 pi and then sine of u du. So that is something that's very important. You have to change your 0 and 1 to whatever it would be with u's. So now we can integrate. Well, if you integrate sine, you're going to get negative cosine. That's right. So 1 over 2 pi, and then cosine of u. And we are going from pi to 0. So if we plug that in, we have negative 1 over 2 pi, cosine of pi, and then minus negative 1 over 2 pi, cosine of 0, which that actually changes to a plus. So cosine of pi, anybody know? Negative 1. And then plus 1 over 2 pi times the cosine of 0, which is 1. So I end up with 1 over 2 pi plus 1 over 2 pi, which is 2 over 2 pi, which reduces to 1 over pi. And that's what you would want to leave as your answer. So it's basically a continuation of u substitution. We do use substitution, and then we also have to change the limits of integration. Now, the way that you can avoid that is coming up here. Instead of integrating and then plugging in right here, you can go back and you can have negative 1 over 2 pi. Cosine, instead of u, we set our u back up here with pi x squared. So pi x squared, and then you integrate from 1 to 0. And so if you actually go back and plug it back in and put it in terms of x, then you can still use the 1 and the 0. Sometimes that's okay to do, like it's not a big issue, but a lot of times it's going to make it harder to actually plug it back in, and it'll be more work than just changing your limits to 0 and pi. Okay, so now let's look at this question. We're going to use a u substitution. What do you want your u to be? I think it'll be easiest to make it sine of 5x, because we have e to that. So our du, the derivative of sine is cosine, but then we have to take the derivative of this 5x, which is 5, and we took the derivative with respect to x. So looking here, some people find it helpful to write x equals 0 and x equals pi so that they remember to change it later. So if that helps you, you can do that. E to the u. Now, cosine of 5x dx. Over here, we have cosine of 5x dx. So we need to divide it by pi to get that by itself. And so now we really just have 1/5 du instead of cosine 5x dx. So now we can actually integrate that. But before we integrate it, we're going to have to change our variables limit for our upper and lower limits. So I have 1/5 e to the u du. Now over here, when our x is 0, the sign of 5 times 0, well, that's the sign of 0, which is 0. And then when my x equals pi, u is the sign of 5 pi, which is the same thing as the sign of just pi, which is 0. So our integration limits are both 0. Now, when the limit integration, the upper and the lower are both 0, this integral is actually going to be 0. You don't even have to evaluate it if you have the same lower and upper limits. The reason, what is the area under any curve from one point to itself? Well, the length of that rectangle here is a 0. So it doesn't matter what the height is. 0 times the height, your area is still going to be 0. That's if you want to think of it with the graph. Or you can actually plug it in. You can integrate to get 1/5 e to the u from 0 to 0. 1/5 e to the 0 minus 1/5 e to the 0. Well, that still gets you back to a 0. So you can do it either way. But at any rate, your answer for that integral is 0. Okay? So the book gives you a proof of the substitution theorem for the definite integrals, the u substitution. If you're interested in looking at that, you can on page 345 and 346. If you're looking to see a little bit more in detail where that comes from. But for your homework, you get to omit number 11 and number 12. And so make sure you do that tonight. And then we'll go over any questions that you have tomorrow.